Hey everybody, this is Larry. This is the first day of the December Leetcode Daily Challenge, right? Yeah, hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this particular problem. And yeah, if you're new for this month or whatever and you haven't seen this channel before, we will do every problem this month. So come to Discord, come solve problems with us, and yeah, and just chat and all that stuff. Anyway, okay, today's problem is house robber. Which one is house robber? Okay. Oh, and I'm usually solving these live, so if it's a little bit slow, just fast forward or whatever you need to do, or watch it on the faster speed. And if you really just want only the explanation and not, I don't know, you don't find someone solving if you don't find an experienced engineer solving this problem interesting, then maybe this isn't the video for you. Anyway, okay, let's see. Each house has money. These house robber things. I think I made this similar joke before, where I feel like I say this thing enough time, I'm gonna get like a visit from the cops or something. But okay, so basically you cannot select. So, okay, so you have n amount of n houses. You want to select as many of them as long as not two of them are adjacent. Is that the thing? Okay. Yeah. So then, first thing you can do is just do a sort of a brute force, right? Okay. So I mean, just to give a little bit of a spoiler, this is going to be dynamic programming. The way that I'm going to implement it is through memorization, and the way that I'm going to think about brute force maybe is something like, um, hmm, let's just say, you know, let's say we have some list of houses, right? Why would they call it nums if they, you know? But anyway, yeah, and then if length of houses is equal to zero, that means that you have nothing else to do. So this is going to just return zero. Otherwise, you have two choices, right? You could either take the first house or not take the first house, right? If you take the first house, then what happens? If you take the first house, then you cannot take the second house because then people would know, right? Because that's too adjacent. So then that's something like this. Oops. Um, take this house and not take this house. It's just this because, well, yeah. Well, take this house. You have this plus houses sub zero, something like this, right? Um, and this is basically brute force. As hard as it goes, it's probably you get a recurrence that's similar to Fibonacci, right? Because in a way you're looking at something that jumps two step and something that jumps one step. So that's why to me, the complexity is probably going to be related to Fibonacci, which people may say is to the end, but I guess to be more pedantic, it's closer to like, phi to the n, which is 1.616 to the n or something like that, right? Some. So anyway, this is so. Let's say we take this house, then the value that we get is this, right? Taking this house and then taking house value. Otherwise, if we don't, then we have this other thing, right? So let's call this naming thing is aside. Taking house and then maybe while you're not taking house, and then of course the best answer is just the max of either of these two, and that's our answer, right? And then of course we start by calling it on nums, though you could have just called it by itself, but that's fine. So yeah, so this looks good. Let's run another test case. So that looks good as well. So of course the issue is now, let's say we have, I don't know how many that is, right? But the reason why this, like I said, it's going to be exponential. It's going to be 1.6 to the n, roughly, phi to the n, 5 phi. Never know how to say it. And of course, if you have that, given this n, I didn't count how many this is, but even for for n is equal to 30, that's going to be too big, and n can be up to 100, right? So the first thing to optimize is to note that what happens. We only care about the first house or the first two houses or something like this, right? And that means that we do not need to pass in the entire nums every time, because right here, the way that we're doing it is that we are passing in the reconstruction of the array every time, right? This is the entire array minus the two items. This is the entire array minus one item. So one way that we can kind of save on time is noticing that we never change nums, right? We never change houses. We never, the value just stays the same. So we can represent this very roughly by saying that, n is equal to nums of, and here we can just relate this to, say, an index of the house, and then now instead of looking at this, we can just say, I still prefer to call it houses. So I'm going to rename the variable, because this is, this is a little bit awkward, right? So then now you start by 0 index, and now if index is equal to n, that means that we ran out of houses. Otherwise, we go houses. Otherwise, this is index plus 2 and index plus 1, right? Hope this makes sense. But basically what we're doing now is just, we have no reason to make sublists. We only care about the first two items anyway. So this will allow us to access just the input by itself. And of course, after every major change, we should run the test to make sure that we're okay. And of course, in this case, we're not, because I wrote index is equal to n, but of course, this can actually be index greater than n, right? Because in this case, it could be n over n plus 1, because if index is n minus 1, and then index plus 2 is n plus 1, right? Now you see that it works. Of course, we still have that timeout issue if we have the big list. That's why I kind of took it out of testing, just to make sure that we have a look for it now. But so when we run it, you'll see that it's still get the time limit exceeded and so forth. So then the second thing is noticing that, okay, for every same input, if we put the same input here, given that the houses are the same, given the same input, we always have the same output, right? It doesn't change. There's no randomness. There's no, the states don't change. So therefore, we can just do what we call memorization, right? We can memorize the input. And how we do this, there are a couple of ways you can do it. The way that I'm going to show you for understanding is, okay, let's think about this. Well, in this case, index can go from 0 to n plus 1, like we said, right? This is O of n, of course. So now we know that the index can only have a fixed amount of inputs. So then now for each input, we want to do two things. We want to store, we want to just store it down, and also calculate, do the calculation, right? So of course, that's what this function is doing. So we can just write something like has cache of is equal to, let's just say force times, we could say n plus 2 in this case, because 0 to n plus 1, but you can also have another bound if you want to see how to do it, but that's how I would do it, right? And the actual cache itself, and then here, of course, we wrote if we have the cache for this index, that means that we've already done it before, then we just return the cache value. Otherwise, at the very end, we write the cache is equal to true, and cache of index is equal to this thing, and then we just return it from cache. right? And then now once we run the code, this should be much faster. Has index, whoopsie daisies, has cache. Uh, it'll be running much faster because you have incorrect indexes. But also once you fix those, they'll still be much faster. So yeah, so now let's give it a submit. And apparently I've done this twice before, almost a year report. 610 day streak, nice. So that's fast enough. And yeah, so as you can see, the space complexity is just these two things, because for every possible input, it will take all of one space. So it's going to be all of n space in total. And of course here, we just assume that now this is going to be, these calls are just a lookup call, because we know that these are, saved. So you only do them once. So this entire thing has O of 1 operation as a result, because they're O of n inputs. Each input takes O of 1 work. So total work or time is equal to O of n time. So that's pretty much it. So we have linear time, linear space, and that's pretty much it for this problem. Let me know what you think. I probably explained it previously okay as well. Let me know if that video was better, if you want to go back and check on it. That's all I have. Yeah. Congrats on the first day of December. Stay good. I'll see y'all later. Remember, we'll do this every day for this month, so stay good, stay healthy, to good mental health. I'll see you later, and take care. Bye-bye.